In this video, I show how I measure the surface distance of a 1 arc-minute east-west longitudinal straight line using a total station optical electronic distance measurement, as well as a rolling trundle wheel distance measurement. I determined endpoint positions by both GPS and by landmarks visible in Google Earth. I found that the measured distance was very close to the predicted distance, and in fact well within the margin of error expected from a consumer-grade GPS receiver, which was only allowed to average for a few minutes at each end. Alright, the goal of this measurement is to measure the east-west distance, surface distance, in meters at my latitude for 1 arc-minute of longitude. So what I've done here is I've picked out a straight stretch of street, and I've picked 2 points that are about 1 arc-minute, or 1 arc-minute of longitude apart. And I'll show you the coordinates later. So this is where my target was. There was a retroreflector on this power pole here. But then I went up to the top here, and for my first measurement I used my Nikon DTM 420 total station because it has a built-in rangefinder that will measure the distance off of retroreflectors. So I parked here on the shoulder, and I got pretty close to lined up with this house wall here. So I was right in here somewhere, probably right about here at the end of this left-hand red line. The point of the pin is where my Garmin eTrex 20 handheld GPS told me I was, but it quite likely could be off a meter or two because I only let it average for a few minutes. But this is basically where I was standing when I shot the distance with the total station, and you'll see that video later also. Oh, and you will see that I also turn the total station 90 degrees to the red line and sight to the peak of this roof, so you can see that I am in fact very close to perpendicular to that edge at the end of that house. I averaged the locations, the latitude and longitude, to give the average so we could compute based on my average latitude. And then down here is where my reflector target was. And you can see that it looks like, see, this is the shadow of the pole. Looks like the base of the shadow is right here. And you'll see later in the video that straight across the street was kind of a gray manhole cover, which you can see right here. And you could also see these transformer boxes and stuff here, but the manhole cover was what was really straight across. And I let the GPS average for a few minutes there, sitting on one of the guardrail posts. This is a guardrail here around the telephone or the power pole. So I let it average there for a few minutes. So that's what the point of this yellow pin represents, where the Garmin eTrex 20 handheld GPS said it was. And so that is my setup for measuring the distance between 2 points that are about 1 arc-minute of longitude apart. So you can see, I'll just do a couple things here. Put this right here. This is just going to be rough because I'm not going to take the time to zoom in and get the exact spot. But you can see this is about 1242 meters or so. And you can also see that this is pretty much parallel to the end of that house, which you'll also see in the video. And you can also see that the north to south slope here is about 5.8989, whatever. Almost 6 degrees of deviation from exact east to west. But the math says this only offers or causes about a 0.5% error in the measured distance, which we account for later. So there you have it. That was my setup. And next we will do the videos showing the measurements and the endpoints. Alrighty, I'm at the upper end of the shot. As you can see, I'm right across from this guy's house, right in line with the end of the house. And you'll see that on the Google Earth. And I'm measuring the downward slope of 16 arc minutes and 10 arc seconds or so. But the important thing is, I am measuring 1,241.7 meters to this telephone pole down here. You can't see it, but there's actually a retroreflector on that power pole right centered on the crosshairs, and that's almost a mile away, about 4,000 feet, over 4,000 feet away. So you can see I can hit a measure. It says it's got a good signal, and there it measured the distance in meters. So now, just as a locational reference, I'll turn 90 degrees, also known as 270-ish. There's the peak of this guy's roof, and 268 degrees from me, so I am lined up really good with that guy's roof. And I got my GPS up here, averaging a location. I've got good confidence. I'll let that go for a few more minutes and save that average GPS waypoint for this location. I'm going to go ahead and save that now, since it says it's got a confidence of 100%. Okay, done. And I will go into Waypoint Manager and look at the one we just created. And that's my location. Alright. Now I gotta go get the GPS location for the other end. Alright, now I am at the lower end, averaging a GPS waypoint. This is the telephone pole I shot at. I'm looking straight across, so I'm at the same distance. Up there was where I was, way up there. So there's my GPS, and right here is the telephone pole with this interesting reflector thing up there. And I was able to actually get a EDM laser bounce. Well, it's not a laser, it's just infrared LED, but a bounce off of that, and I was able to measure the distance from way up the street. So there's that other little road I was at. There's my GPS. And you can see this is straight across from pretty much another pole, and over to the right, just slightly about 10 feet, is a bunch of boxes and stuff. Maybe those will show up on Google Earth. They're like power transformer boxes and stuff. Taking our time on that. Nice little horsey over there. There's a power transfer station there. That shows up on Google Earth. I remember these when I was a kid in eastern Washington. They're kind of a yellow flower. Well, now wait a second. This one looks purple. I didn't know those came in purple. Interesting. Wild poppy. Okay, looks like we got 100% confidence level on the GPS, so I'm gonna go ahead and save that. Done. And I'll go back to Waypoint Manager, the one we just created is, and there's the coordinates for the one we just created. So there you go. Alrighty, I am out here near my starting telephone pole with my little wheel counter. Haven't reset it yet. Got a GoPro mounted. Here I am. The pole is straight across. And right here, straight over there, is the manhole cover. Now I gotta reset this thing and go for a long walk. There's our pole. Since it hasn't started raining yet, I stuck my umbrella in to extend it. Alright, I've reached the destination at 1242 meters. You can see I'm right in line with this house. And now I need to reset it and turn around and go back. Now we're getting a little bit of sunshine. I checked my Google Maps. It says I'm doing about 3 miles an hour. Alright, we have arrived at our telephone pole, straight between the telephone pole and the man cover, and we have got 1,242.5 meters. And I guess that's what we needed. Alright, this is the math and the details for this project. So, date performed, that's today as I record it. The type of measurement was EDM, which is electronic distance measurement, as done by a total station, a Nikon DTM 420 total station, and a trundle wheel, which is a little rolling wheel on the ground, which you will see, which measures distance. The two endpoints are listed here and here. This is the east location, latitude and longitude, and the west location, latitude and longitude. These are obtained with my Garmin eTrex portable GPS unit, which is old, but it works. And then the average is just, the center location is just the average of those coordinates. See, I can click on it. You can see it's just the average of this one and this one. Same there. And the EDM distance, this is the measured distance that my total station gave, 1,241.7 meters. Rolling the wheel westbound gave 1,242.4 meters. Oh. This is performed. Blah. Okay. Might as well go once too. Okay, so this is rolling the trundle wheel westbound. And I got 1,242.4 meters. Rolling it eastbound, I got 1,242.3 meters. Now calculating the distance from Google Earth in meters based on the GPS-derived coordinates. So in other words, these sets of coordinates up here, Google Earth says that is 1,240 meters apart. Using Google Earth distance based on landmarks visible in Google Earth, it's around 1,244 meters. Using just the Haversine formula, which is pretty long, and which assumes a perfect sphere, and using the Haversine formula on these coordinates, gives a distance of 1,237 meters, using the GPS coordinates as the coordinates. This is the north-south slant of the straight line. It was almost 6 degrees, 5.98 degrees, deviating from true east-west exactly. I could have done it on a street which was was exactly east and west, but I couldn't find any good parking and I didn't want to get in trouble by parking in someone's yard. And this is the longitudinal distance in arc minutes between, as you can see, these two longitudes here, here and here. So like this is basically just this minus this times 60 to convert degrees into arc minutes. Alright, and down here is what we would expect on a globe Earth. The globe circumference at the equator is 40,750,017 meters. Now, because I'm at 48 degrees north, roughly, I'm not at the equator, so the circumference at my location would be less. So you can see we're taking the cosine of my latitude times the circumference of the equator to get my circumference at my latitude. So at my latitude, the circumference is 26,760,387 meters. And this, of course, is assuming a perfect sphere. Now, at my latitude, the meters per longitudinal arc minute is 1,239 meters. But you'll notice that the arc segment that I measured wasn't exactly 1 arc minute. It was 0.99378 arc minutes. So I need to apply the correction for that. So this is the meters of longitude that I should have gotten even though I was at 0.99378 of an arc minute. And so this is just this here times this here to give the actual expected meters of east-west direction that I should measure. Now, because of the almost 6-degree slant towards the north-south, that I do need to add in 0.54% to the distance because that increases the path length slightly. And so this is just the 1 minus the cosine of the slant angle of the line. And finally, this is the globe predicted point-to-point distance after having taken into account the fact that it's slightly less than 1 arc minute and the fact that it's slanted at almost 6 degrees. So the globe prediction based on these assumptions of a perfect sphere and all that stuff is 1,238 meters. So you can see that the 1,238 meters is surprisingly close to what I measured up here. I was hoping it would, well, maybe it will let me. Nope, it won't. So you can see all of my measurements, the one with the EDM on the total station and then the two with the trundle wheel, were all very close, all within a meter of each other. So I suspect that there was probably a couple of meters of error with the GPS because I didn't let it average for more than just a few minutes at each end. So that's probably the source of this few meters of error. So there you have it. It matches very closely, well within the expected accuracy of using a consumer grade GPS and only letting it average for a few minutes.